Okay, so this is the notes for 3.3 where we're dividing polynomials, and we're going to look at a couple of theorems, the remainder, the factor theorem. We're going to use two different types of division. We're going to use long division and synthetic division. Synthetic division is way simpler in that we don't have to make as many choices, but long division does always work, and that's sort of the nice thing about long division, is it will always work. And because the x's are there, in some ways it makes a little bit more sense to see the solution. So first thing we have to look at is dividing here. The goal is to make this x become an x squared. So the question is, what do we multiply x by to get x squared? The answer to that is x. Now if this x were to distribute down here, I would get x squared, but I would also get plus 3x. In division, whenever we do this, we would always subtract this line. Now, for the sake of my own sanity and not making sign errors, I always just switch the signs of everything in this line. Rather than putting a minus out here and trying to remember that I'm subtracting 3, I just switch it to a negative. The x squareds will cancel, and 10 minus 3 is 7x. I'll bring down the 21, and then I say, okay, well now what do I multiply the x by to get a 7x? That's my new goal. Well, to get a 7x, I'm going to have to multiply by a 7. And that 7 multiplied through would give me 7x plus 21, which again, I want to subtract that line, so I'm going to make both signs switch. The 7x is cancel, the 21's cancel, and this has a remainder of 0. So the solution of x squared plus 10x plus 21 divided by x plus 3 is x plus 7. What that means, if you think about numbers like 10 divided by 2 is 5, that means that if I multiplied the original or the outside pieces here, then I would get the 10. So here, if I took x plus 7 times x plus 3, I would get x squared plus 10x plus 21. In other words, division is a type of factoring, where we're factoring but not by the traditional guess and check method. We're forcing the factoring to work. We can look at another example of this long division. The 3x, to make it a 6x cubed, I would multiply by 2x squared. Okay, so let's keep that going. We got 2x squared. If I multiply 2x squared by my 3x, that will become 6x cubed, and 2x squared times a negative 2 would be negative 4x squared. But again, I'm going to subtract this line, which means to change both signs. The x cubes are going to cancel. We have a negative 1x squared plus 4x squared. That's 3x squared minus the 5x plus 4. I'm going to bring those down. Now my goal is to turn the 3x into a 3x squared. That's only going to take an x, because x times 3x would be 3x squared, but x times a negative 2 is negative 2x. But once again, I'm going to subtract this line, which changes both signs. The 3x squareds cancel. I get a negative 3x plus 4. Well, this time to turn a negative 3x or turn a 3x into a negative 3x, I need a negative 1. Negative 1 times 3x is negative 3x. Negative 1 times negative 2 is a positive 2. But I need to subtract the line, so change the signs. Those cancel, and 4 minus 2 is 2. Now 3x cannot be turned into a 2, so I just write the remainder, 2, and I could not divide it by 3x minus 2. This right here is the entire solution. All the stuff that did divide, and then the piece that I still couldn't manage or deal with. Now there is an easier way, at least in most people's estimation, how we might be able to simplify the division. We're going to use synthetic division. Okay, instead of doing this traditional division, which requires a lot of thought, we have to do a lot of thinking about, well, what number goes here, what number goes there, what do I multiply by? We're going to do something a little bit simpler. This is synthetic division. You can think of it as a fake or a sort of a magic division if you want. What we're going to do is we're going to take the coefficients for all these numbers, which would be 1x cubed, 4x squared, negative 5x, and then a positive 5. I always put the positive 5 over this box here. And then I'm going to take this information and put it out here, but I only want the number. Now we have a rule that I use when it says whenever something's grouped with x, we take the opposite, or what would make it equal 0. So because this is x minus 3, I'm going to use a positive 3 here. To run through the process of synthetic division, we are going to add, out, and multiply in. So 1 plus nothing is 1. But to get back in, I'm going to times by 3. 1 times 3 is 3. I'm going to add out. 4 plus 3 is 7. To get back in, I times by that 3 again. 3 times 7 is 21. Negative 5 plus 21 is 16. And 16 times 3 is 48. 5 plus 48 is 53. Now, you might look at that and say, how does that help me? Well, because this was an x cubed and I just divided by an x, I know that this is now an x squared term. The 7, the next term would be the x term, and the next term would be my constant. So x squared, x constant. You might say, well, what's the 53? Just like the 53 has the bar under it, 53 becomes the remainder, plus 53 over x minus 3. This right here becomes my whole answer. And that, I never had to think, well, how do I make x into a 4x squared or into a negative 5x? I didn't have to ask those kinds of questions. I just did the number part. Multiply and add, multiply and add. So that makes it pretty quick to get through the process. One of the things that we learn about the remainder theorem is that if this value down here is 0, okay, if it equals 0, then it factors. Then that's a factor, okay? Meaning that we could write x minus 3 times something, and we would get the original, okay? Now this one did not equal 0. So it doesn't actually divide evenly. That's what we mean when we say it factors, is that it would divide evenly. But one of the other cool things that we learn is that whatever the remainder is, okay, whatever number does pop up down there, that is actually the answer for plugging this 3 in for x. Now, most of you would say, well, why don't we just plug 3 in for x? Well, that will only give us this number. It's almost that we just want to point out, hey, that's an interesting fact, more than it's something that we use in a daily routine. This is just something that, hey, did you ever notice? And so that 53 is the same if I plug 3 into the x. What it wouldn't give me is all this information over here. I don't know those numbers unless I do the synthetic division. So if I want to know f of 2, I could either plug 2 into x in all these equations, or I can run the synthetic division. Now again, most of you would say, I would rather just plug the 2 in, and that's fine. But I just want to show that it works. The 1 would drop down. 2 times 1 is 2. Negative 4 and 2 is negative 2. 2 and negative 2 is negative 4. 5 and negative 4 is 1. 2 times 1 is 2, and that would give me 5. So 5 would be my answer. Well, if I put 2 in here, 2 cubed would be 8, minus 2 squared is 4, times 4 is 16, plus 2 times 5 is 10, plus 3. This right here is negative 8, plus 10 is 2. 2 plus 3 is 5. It was predictable. We could find that information pretty easily. The last thing that we want to point out is that if it's 0, it's a factor, and we should be able to find all of the zeros. So what I'm going to do is I'm going to run the synthetic box. 2, negative 3, negative 11, and 6. And then I'm going to plug in the number that they gave me. They said 3 would work. So the 2 drops down. 2 times 3 is 6. Negative 3 and 6 is 3. I'm adding out. I multiply in. 3 times 3 is 9. I forgot my box in here. Negative 11 and 9 is negative 2. 3 times negative 2 is negative 6. And it produces the 0 that I was hoping for. Now I would like to find all of the zeros. Notice it's an x cubed equation, which means I'm looking for 3 solutions. But I only have 1. That's the number 3. I need 2 more. Well, the way we can do this is by making it 2x squared, because it was x cubed, it is now x squared, plus 3x minus 2 equals 0. And we want to factor this and solve it. I can use the quadratic formula. I can factor. I could also graph. But I'm just going to go ahead and factor it. 2x squared would be 2x and x. The 2 over here would have to be a 2 and a 1. Now I have to guess and check my way through this. I'm going to do 2 here and 1 here. This is 1x. This is 4x. Because the 2 over here is negative, it means my signs are different. So if I made the negative 1 right here, that would add up to 3. So I'm going to work this out like that. Well, I still need to tell what makes these two parentheses 0. Over here on the right, a negative 2 would work. Over here on the left, you have to switch the sign and divide by that 2, which makes it 1/2. And then, of course, we have our 3 that we started with. We found all 3 solutions. So there's going to be different approaches. Early on, they'll be nice and easy to find using factoring. Eventually, we'll get to things that don't factor so well. But hopefully that'll get you through 3.3, and then we'll look in the future at 3.4 and so on. Good luck.